Hi everyone, thank you so much, Dylan. Thank you for the talk. Very, very entertained. I have to admit, I was dared by my coworker to play Raise Up by PD Pablo before starting this talk, though in order to keep a copyright strike from happening, I think I'm going to not do that so we can all prevent ourselves from taking our shirts off and waving them on top of our head like a helicopter, because that violates code of conduct as well. My talk is called Untitled WHIP Presentation, where I'm going to be talking about WebRTC-based things. I know this is in a movie theater, and I know that the WHIP puns are going to be just coming everywhere, so I figured I might as well get it out of the way by putting an Indiana Jones picture on there so that we can just get all those puns. But as a quick little introduction, my name is Griffin Kale. I am a developer advocate at Dolby.io, where we work on a lot of things, including real-time streaming and video communications as APIs, and just thought it was a really cool fit. I actually was at HalfStack in Arizona earlier. That was my first one, and now I'm here speaking at it. So I enjoyed it so much, and let's get started. So, I don't like assuming anybody knows everything all out of the way. Like, if you asked me before I started working on this at Dolby, and you asked me, what is WebRTC? I would have been like, I've heard of it, but I don't exactly know what it is. So I'm going to do you all the favor of just kind of giving you a brief little overview. So it's been around since 2011, with the 1.0 coming out in 2018, so it's still relatively new, especially for web technology, where it's all about doing web native audio-visual communications. And some of the benefits over the old ways of doing it are that it is end-to-end encrypted, you don't need any plugins, it's web native, it's peer-to-peer, it's free and open source, and it's super, super fast. And you've probably already used it. If you've used Skype in the background, Skype was based off of this. If you use Zoom, you're going to be very familiar with using this, and it's a very common way for you to be able to stream video in live streaming, all these things, to different users on the internet. It's based off of a couple different JavaScript APIs, MediaStream, RTC Peer Connection, and RTC Data Channel. And what I find kind of fun in my little research for this presentation is that we can take a look at the first example of WebRTC being used on the internet from this Ericsson website. Unfortunately, the video part isn't necessarily working, but we can actually take a look at some of the code that they used to build it over here. Unfortunately, the video isn't working. This was originally done in 2011, but for some reason the CSS is broken when you take a look at it. So we can take a look at kind of what they're doing over here with their JavaScript in defining these different video devices and using these native elements, which I think is a cool little part of history, but it's not the most fun thing to do in a presentation, just to, read someone else's code and just kind of traverse that. So let's continue on talking about WebRTC versus the rest. So WebRTC kind of came as a way to replace some older ones. The common example I'm using as the comparison here is RTMP, where there are key benefits to using WebRTC, where it is, as I mentioned before, super fast. You can get sub-500 millisecond latency end-to-end on using WebRTC-based communication, whereas RTMP typically takes around 5 seconds for it to get from end to end. RTMP was designed for Flash video, if any of you remember the Adobe days, whereas this is modern using HTML5. You can use adaptive bit rates, which means you're able to change the quality directly within there instead of locking somebody into a specific resolution, whether you're targeting something that's lower, so everyone with all internet connections can do it, or targeting something higher, so it looks good, but not everyone's able to use it. But there are disadvantages in terms of scalability and association with poor quality. I'm sure a lot of you have used Skype or used Zoom, and it's not really known as the best quality picture and audio that you're getting in the world. Like, you're not going to do a full broadcast with somebody over a Skype call. You're going to use some different software for that. So here's kind of an example of the delay I'm talking about. This is from, I believe, one of the NFL interviews, where you're gonna hear some of the latency as an example. Let's see how this works.
To the Superdome, Armageddon is there with new video from the moment the game went dark. It is a story only we can bring you. Armin, good morning. Good morning, Charlie. Good morning, Nora.
Whenever you hear those people switching from the people in the studio to the people who are live at the production, there's always a bit of a delay. I'm not sure if any of you noticed that, where there's kind of a tick, tick, tick before they start immediately responding. And that is not all due to the delay of streaming, but I think it's a very good way to illustrate a lot of the issues that kind of come from the traditional way of doing large-scale broadcast, like a sports announcement or some other news announcement, where I was able to count using my little jank Google timer thing that I made over there, that it was 1.6 seconds of delay between the person in the broadcasting center and the field reporter. But that's even taking into consideration all of the different advantages they have. They know what the line is going to be. They have people leading them on, telling them when they're supposed to go on. Everything's playing towards their favor to reduce that delay, yet they're still getting over 1.5 seconds of latency in there. And we can reduce that. So in comes WHIP. And let's take a look at what I have on this link over here. Okay, so we have an IETF dashboard over here. Okay, abstract, this document describes a simple HTTP-based protocol. Okay, I have ADHD. I'm not going to be able to read all of this right now, and that's what I'm here for. Giving you a quick little explanation of what WHIP is for people who are not as smart as the very smart researchers like Sergio, who wrote that IETF documentation, as a quick little start for this. So, WHIP stands for WebRTC HTTP Ingestion Protocol. It is an open standard, and as you just saw, it is IETF supported, where it is meant to replace older codecs like RTMP and SRT. It's all based on HTTP post requests, and it's all about kind of taking advantage of these things in a very simple and organized manner, with load balancing, with authentication done via the HTTP protocols with the bearer tokens, and it's useful in browsers and native encoders. So we have open source solutions like GStreamer, Osprey Talon, Flowcaster, Lyrics Broadcaster, Media Soup, a lot of these different things ranging from, well, we have the hardware stuff like, oh, come on, Logitech Spotlight. We have some of the hardware stuff, whereas this is a mobile app, Lyrics Broadcaster, that you can download on your Android or iOS right now, and I'm sure a lot of us are familiar with OBS. And we can take a look at what this is going to look like with, I use this analogy where you have like kind of the train, the train people who are organizing which track's going the right way. WHIP is here to do that for the WebRTC-based WebRTC-based kind of protocols and communication that's going on, where they're going to be directing all the different traffic in a way that the servers are going to be able to understand and interpret it in the right way. So I have a little demo. Let's see how well these go. There's knock on wood that these live demos always work, where I'm going to be using a fork of OBS that you can see. This is a GitHub article over here, where I'm able to use WHIP because we have implemented it directly in here. If you look in the settings, it is exactly the same as normal OBS, except on the stream section, we have different services over here, so we have enabled WebRTC. I have obtained a stream name and a publishing token already from our APIs, and we have support for a bunch of different codecs like H.264, VP8, VP9, AV1, and we're able to stream directly with WHIP. So I can just click on start streaming. This is just the desktop and me right here, so you're gonna see double of me, have fun. And if I go over to my dashboard where I have obtained my API key and everything, I am able to go look at the playback by looking at the hosted player, where we can view it directly in our browser. So what we should be noticing, even though this is in 24 FPS and under Wi-Fi instead of an optimized network, I can do things like wave my hand, and it tends to be pretty quick. Uh-oh, this one's not very fast due to these suboptimal conditions, but we can look at the media stats instead and see what's actually going on. So the real-time trace, we're getting about 65 milliseconds of latency from OBS over to our servers. And that's where WHIP comes in. WHIP is only the ingestion, not the egress of this. We're going to get that in a little bit. And by optimizing this, we're reducing delay as much as possible through all these different networks. And we're going to kind of get back to this in a little bit, but we're able to kind of see some really cool things in terms of that. And these are all open software once again. where we actually have an active PR on the OBS project of getting WHIP directly implemented in there as the open standard. So it doesn't just have to be via Millicast servers, it can be through any WHIP provider out there. So definitely go check that out. That should hopefully be added to mainline OBS relatively soon. Now let's talk about WHEP. So when there is ingestion, there is egress. And if I click that again, it's going to be another one of those IETF documents that my ADHD is not going to let me pay attention to. So I'm going to skip that joke again there and go over to me explaining it. So once again, WHEP stands for WebRTC HTTP egress protocol. And the whole idea here is that it's about distributing those streams from the servers that we have then ingested all that data to out to all of the devices. And the big difference here is that ingestion is usually only one device in, but egress, you're going to likely be sending it to multiple different devices. The whole idea of you are one streamer and ideally sending it to hundreds, thousands, maybe even millions of different people on the other end who are going to be watching it. So because of this, you do need to have some more flexibility in the way that the protocol works. But the whole idea is standardization. If we're able to standardize what the communication looks like coming out from these servers, then the device manufacturers are going to understand, all right, this is what we're expecting, and we can optimize that. So we're able to make it a lot more modular. There's no custom JS needed. It's all able to be done directly on there, and it's interpretable between all these different devices. So there's a couple of examples out there where if you want to watch it on your phone or your browser or on a professional broadcast, we have some ideas of kind of how you might do that. Video.js, we've built a plugin. We have GStreamer and we have Janus as some open source implementations of this being done in a server that you're able to actually see. And kind of as a nice little visualization, I made this very shoddy thing in Miro where you're going to see it's going to start off with the broadcaster and they're going to have an encoder, whether that be software, hardware, or something else. That's going to be sent using WHIP over to the CDN. Dolby is one of these CDNs. Cloudflare, I believe, announced that they have their own CDN for WHIP and WHEP now, which is pretty cool. The more people following these standards, the better, because once there's more adoption, the more standard becomes viable. If there's only one person using that standard, no one really cares. And then it goes from the CDN via WHEP to your decoder, which can be, again, a phone, a browser, a TV, something like that, over to the viewer so that they can go and consume that content. So this is a really cool little demo that actually just got released to the public today, where we're using Video.js, because at the end of the day, we are very much JavaScript enjoyers at this conference, to be able to consume a lot of this content via WHEP. So I'm going to start my WHIP broadcast on OBS over here as our open source way of being able to do that. But then on my code over here, I have my own little server over here, which I can use npm run dev. This is just a quick little Vite server. I'm not sure how you pronounce anything on the internet because I always type it and never pronounce it. But we can.
GIF, I know that.
GIF or GIF, that's going to be on the pub quiz too. But you can see what's going on is we have a plugin that's soon going to be going over to the npm repos that we're able to read directly in this pretty simple main.js file where we are able to get the plugin via Video.js and broadcast it using the CSS and the everything that's just kind of directly imported. So not that much needs to go into it. We can go into the local host file of the server that we just started, and we're now going to be seeing us directly via WHEP. So it should be a little bit faster, still a little bit slow. It's usually a lot faster at different networks. I blame the network. I always blame the network. Or Canada. But we're now able to do a WHIP and WHEP fully balanced instead of having to use older kind of loopback technologies to get this all working. We can take a little bit more of a look at everything that's going on in terms of like the HTML is pretty basic just to make sure we have some CES. And then the actual codec itself has support, once again, for that simulcast with multiple different bit rates. So you're able to see those if you're using a broadcaster that supports that. So unfortunately, this OBS one doesn't, but if you did it directly via your website, that would work. But that's kind of what's going on. It's not necessarily the easiest thing to show off directly in person, unless you're in the broadcasting sphere and you really, really love optimizing your milliseconds to the individual millisecond. But definitely go check that out. Going pretty quickly here, so I'm going to kind of close things off by just trying to see if anyone is interested in the whole live streaming and video industry in terms of if you want to learn more, definitely check out the mailing list. I might have some answers for you, but there are some much smarter people on the internet who are actively doing a lot of research and developing these standards. So definitely take a look at that mailing list on the IETF if you want to learn more. I am not on Twitter, so follow me in Mastodon at Griffin at Masto if you want to actually follow me. I never tweet or toot or whatever we call it these days, so I will not spam your inboxes. And I'm at most other things at Wing and Griffin. Thank you so much for all doing this. I know we're getting up to a break next, so I'll probably end it here unless we have any questions. The question was, how do I improve the quality of my podcasting? Or do you want more specifics than that?
With some of that.
Yeah, with some of this. So this specifically is for the streaming aspect of it. So if you're trying to do a live podcast, this would be a very good option for you to do that, especially if you have live audience participation. Because the latency would be very low, you would have much lower of a gap between people being able to ask questions, be able to post in the chat, be able to do live reactions. So we see a lot of value in this in the live performance in the sports industry and a lot of different areas like that. For the actual audio podcast area, that actually would be more of the direct communication between the two of them. So you would want to be using some kind of voice call software instead of voice streaming software that has higher quality stuff. We as Dolby do also provide that, but that's not necessarily this specific product that I'm talking about right here, where you want to make sure that they're using up-to-date codecs, using like well-optimized networks, if not peer-to-peer, which was why Skype used to sound so bad, because everyone had really bad networks in the day, so they couldn't transmit high-quality data very well. And also just making sure you have some good post-processing. You can get a lot done with good stuff. I remember some people were talking about how I think Becca actually lost some audio from one of the last ones, and they were able to clean it up with AI to the point where they couldn't even notice that it was AI that cleaned up the quality of the audio at the end of the day. So there's a lot you can do in the post-processing area if you're not doing a live stream, but if you are trying to do a live stream, this would be a very good option for increasing the quality of that, aside from, you know, buying better equipment and things like that. Yes?
So typically I use like Restream.io
Mm-hmm.
distribute to multiple platforms. Recently I use Ecamm, and Ecamm now has the ability to, you know, shoot out to multiple platforms as well. So how would something like this integrate or help out those two options? Because right now we're using RTMP. Is this a replacement for that?
Absolutely. That's actually a very wonderful and very relevant question. So yes, you're correct. And a lot of those are using RTMP. And unfortunately, a lot of the stuff relies on the streaming providers to provide support for these different codecs. It is gaining a lot of popularity very quickly, so I do anticipate a lot of these ones are going to support WHIP pretty soon, and then WHEP then has some more areas where you need to have some more people support it. But it is something that is completely meant to and has support for multi-streaming to multiple different providers all at the same time. It just needs that those platforms need to support the codec at the end of the day. So if you are interested, definitely reach out to your Twitches, your YouTube streamings, your everywhere else saying, hey, I would love you to support this codec. And hopefully we start seeing it more often.